Hi, so my project's on the 30-day readmission prediction for diabetes patients. So the goal of the project is to predict if a diabetic patient will be remitted within the 30 days of discharge from like a hospital using the Kaggle database called Diabetes 130 U.S. Hospitals for years 1999 to 2008. And once you download this, it gives you a zip file with all the CVS files, and then there's also a study called like the impact of like HBC measurements on hospital readmissions rates, analysis of 70K client database patients record. So this research just investigates whether or not like HBC testing at a time at a hospital admission affects like the 30-day readmissions in diabetics patients. So that's cool. So yeah, I did this project mostly just to learn about since 30 the readmission within 30 days are like major quality and cost concerns in healthcare. By predicting like which patients are likely to be readmitted, hospitals can like improve their patient care by identifying like high risk individuals early and like providing them resources to follow up. As a result, this basically like decreases like the cost of the healthcare and improves the system's overall efficiency. So the first thing I did here was I loaded the data in Collab by using pandas and NumPy. I basically used pandas to read the CVS file, and I loaded the shape of it. Second part I did was basically I replaced any missing values with NaN values. Then afterwards, I basically dropped columns that were missing a lot of their values, like weight, prayer code, and medical specialties. Afterwards, I basically dropped expiration codes with these IDs, mostly because these IDs for patients that are passed away or are dead. So I don't need them if I'm trying to figure out readmission rates for patients within 30 days, as these patients are already dead. Then I basically changed like these intercoded values, category of values, into like readable human understanding. So like for example, so basically admission type ID, right? So this becomes, let's say, number 6. Number 6 becomes null. This becomes emergency, and so on. Mostly, I did this mostly for readability and later on for modeling and stuff. So I did this for admission type map, discharge disposition map, and the admission source map. Later on, I basically replaced like the IDs with like the names over here, basically. After all, I dropped the original IDs, the numbers, and then I basically filtered out the people depending on whether or not these patients will be readmitted within the 30 days, which will be assigned as 1. If they're not, they're assigned as 0. And then I basically, for each column, I removed any ununique variables. Then in this case, I just dropped like values that weren't gonna be relevant, mostly because I'm trying to find like unique things. Afterwards, I basically cleaned the data and showed the data here. Then here you see like the overall data. So this shows us like the unique races, like Caucasians, African Americans, others, the unique genders, the age groups, and this tells us like basically the overall amount of people who will be remitted. So like about 11.4% are remitted, as opposed to like 88.5% which aren't remitted. So yeah, so these are like the first. This is like pre-processing data. Next, we move on to regional database schema. So as a part of this project, I basically stored the clean data set into a SQL database using a SQLite 3. Basically, I imported the SQLite 3 and pandas. I made a database called database readmissions. Then I basically dropped any duplicates for these, as I'm trying to like find out for one patient, so I don't need them again. Then I basically changed the ID for patient's NBR to patient ID to be more consistent. And then I loaded the patient's data later on. Then I basically did the same thing, but with the encounters table. I removed all like the demographic columns from the encounter tables to avoid like classing if any of the columns are missing. Then then I basically ensure like it's the same consistency by replacing the patient NBR to patient ID. Then for this for loop, I basically implemented because SQL like does not support like complex data types like pandas interval. So this loop basically checks like each column, and if any of the values are in the interval, it converts the string to integers to avoid like database errors. Then afterwards, I basically this saves this data and then it loads it, and then this basically makes sure that the table is like correctly made. So yeah. Next thing is like querying with SQL. So the first query is like readmission rates, examines how many patient encounters resulted in like a 30-day readmissions versus those who didn't. So basically, from this we can tell that around basically out of around like 11% basically resulted in a readmission rate within the 30 days, as opposed to the 86,000 that didn't. The next query basically checks the average number of medications and the average length of like the average length of the hospital stay for each patient depending on their readmission status. So basically, this shows that people who are readmitted within the 30 days, they're they're like more like they're like by one value, they're more likely to take more medication, and they're more likely around like 0.4% more likely to stay at a higher average longer time in a hospital. And this can indicate that like higher treatment, like this can indicate that these people are like higher treatment complexity and have like longer hospitalization, which might like correlate with like greater risks at like for early admission. So yeah. So the next query basically, it joins the encounter table with the patient table to create like a 30-day readmission rate by age group. And then basically through this age group, you can tell like the people who have the highest like total encounters are like 15, 25, and then they're also like the same for 3,000 for the total 30 count, and 1,900. And these people have like a readmission rate of like around 12%, which is surprisingly pretty high, but it's not as high as like people who are like 20 to 30%. So that was interesting. So yeah. um Next, we move on to exploratory data analysis. Basically, I use like visualizations to explore the relationship between like readmission rates and variables such as like age group and like number of medication, and then the H1BC levels and the insulin usage. So yeah. So the first chart, basically what I did, I basically used imported pandas and Seaborn for the visualizations. I basically got all the unique age groups like 0 to 10, 10 to 20, and to compute like mostly the readmission rates. I sorted the groups, and then I basically looped through each group, and I basically calculate the mean for that, and then I plotted this. And then this gives us the plotation that people who are like 20 to 30 have like the highest like readmission rates, like around 14%, as opposed to people who are like in 80 to 90s, who are basically have like around 12 to 11% ish. So yeah. Then the next chart is basically focuses on like the number of medication uh prescribed during like a hospital encounter relating to like 30-day readmission. So what this code does is basically it creates a bin like 0 to 5, 10 to 5, 10 to 15. This is like if you take like 3 medicine, you go in this interval, it's like 0 to 5. If you take 13 medicine, you go into 10 to 15 intervals. Basically, and then later on what this line basically does is just groups the data by the medication bill, and it calculates the mean readmission for rate for each bill. And then I plotted this data, and then this chart basically shows like a clear uptick trend from like around it's like 7.5 to like 12, and then it basically dies down later on. So basically, this pattern suggests that the patients are receiving more medication, probably due to like more complex health conditions. So as a result of that, they're more likely to be remitted within the next 30 days. Next one is like the distribution of HbA1c results, which basically this like reflects like the long-term blood glucose control. I mostly did this because of the study in the zip file over here that was talking about it, so I was like interested in like checking it whether or not this affects it. So so what I did then basically, I created the chart here, and then over here I basically converted like the binary targets into like 0 to 1 into like readable strings, yes or no, for like visualization. Then I basically revealed how basically likely a patient is to basically be readmitted within their HbA1c results. And we can see that in the data, at least, that that like people who are like lower than 8% have like this much admission rates. The norm has like this much, and 0.7 has this much. And then in this chart, you can tell how it shows it shows that all HBC group members have like similar proportion of like readmission rates, like around like 1.1. This suggests that while like elevated like HBC might be correlated with like modest increase in like readmission risk, the difference is really not that drastic as seen over here. So yeah. So then I moved on to like checking the readmission rates for insulin. So basically, I was trying to find the analysis. I was trying to analyze the relationship between insulin use and the 30 days hospital readmission rates for diabetes. So I basically grouped the insulin use categories into like ES, or like I basically grouped the data set by the insulin use category and calculated the mean readmission rates for each group. So people who have an insulin status of up have like around like 0.13, and people who have it down have like pretty high. It was like a 0.14. And the readmission rate for people with insulins is like about 0.12, is like 12%, and the readmission rates without insulin is it's like 10%. So this supports the idea that basically that the idea that insulin uses, especially like doses change, may signal more severe diabetic, which could elevate the risk of like hospital readmission. So yeah. So then we move on to modeling logistic regression and decision trees with the exploratory to predict like modeling and stuff. So I basically created like a list of like 16 features on that are considered meaningful for like predicting a 30-day readmissions, and these include demographics, hospitalization info, and clinic indicators. Then I basically created like a data frame that's basically that only selects the selected features, and then the target variable readmission 30. Afterwards, I basically identified all the categorical columns, and I used the PD get dummies to apply like one hot encoding and convert each category into a separate binary 0, 1. This was mostly done because machine learning algorithms mostly require like numeric inputs. So yeah. Then I moved on to the training and train and split data. So I split the data using the 80-20 ratio for training and testing. So basically 80% of the data was used to train the model, and 20% of the data was used to elevate the model's performance on unseen data. And then basically this is the test size reserves like 20% of the data for testing, and then this like ensures a random state ensures like reproducibility. Then we move on to model training. Basically, I trained both of the models, like logistic regression and decision trees, by using skip-learn. So basically, the logistic regression was trained using the LBFGS solver with like a maximum of like iteration of like 5,000 to ensure in convergence on like larger resample data sets. Since basically logistic regression is sensitive to like feature magnitudes, so basically I standardized like the inputs by using standard scalar over here. Then for the decision tree, I trained it with a maximum depth of 5, and then to like try to reduce like overfitting and ensure like interpretability. Then we move on to model evaluation. So I evaluate both of these models using like key classification metrics to assure their performance, and those are like by seeing mostly their accuracy score, precision score, recall score, and F1 score, and using the confusion matrix. Basically, the confusion matrix provides a detailed breakdown of like the true positives, true negatives, and the false positives and the false negatives, which basically allows us for like a deeper understanding of the types of error each model makes. So in this thing, from the we can tell from this result that the logistic regression achieves like a higher recall, like 0.25, meaning it captures more true readmission, while the decision tree achieves as a higher precision and a higher accuracy overall, but has a lower lower recall, indicating like it's missing more like positives. And then this is the confusion matrix for like the logistic regression and the decision tree. Basically, in the logistic regression, it produces more positive false positives as false positives, uh, basically predicting readmission when there wasn't any, and then but fewer false negatives, meaning that it missed actual readmission. The decision tree was more conservative in its prediction, basically, and achieved a clearer separation, but it still costed like high false negatives mostly. So yeah. Then we see like the overall score. So basically, the logistic model achieves an overall high accuracy of like around like 0.6, like 68% in identifying patients who weren't readmitted, and it has a 92 accuracy in like in precision and 70% in recall. However, for like the readmission within the 30 days metric, the model is like showed like limited precision, and but it still had a relatively high recall, meaning that it was basically capturing more true positives, but at the time at the cost of many false positives. Then the decision tree received a high accuracy of like around 85%, and then overall accuracy, and then we're more efficient at identifying non-readmitted patients with like a 90% precision and a 94% recall for the class. However, it struggled with like significantly with like their readmitted within the 30 days patients, as it only was precision for like 26% and only recall like 16%. In summary, basically overall, the logistic regression is more effective at capturing readmissions, while the decision tree is mostly excels in like overall accuracy and performance for like the no readmission class, but is weak at identifying for patients who are going at risk at readmission within the 30 days. So yeah. So what I've learned from this project is like the limitation of like single indicators. So I learned that basically no single factor like HB, such as HB1C, strongly predicts a readmission, as it basically highlights the need for like multiple factor models and multiple inputs to make sure that to check whether a person should be in readmission within the 30 days. I also like understand the challenges in predicting in healthcare. I understand like the difficulty of predicting rare but important outcomes like early readmission, as even with machine learning, it can still be difficult. So yeah, thank you for watching.